All right, so I think the biggest problem is how to go from one frame to another frame. Like this is what the motion looks like in the trees frame. And I just jump ahead and tell you how the scene looks like in the boys frame. So right now I'll show you step by step how exactly I do that. Please interrupt me whenever you have question. So the boys frame is how the boys see the world. So the boy is always at the center, is always at the origin, and therefore the exit of the boys frame should look something like this. I am choosing the center between the boy's feet as where the boy is. Uh, you guys, I just choose it for easy to display what is happening. For you guys, your homework is a dot, is a point, so there's no ambiguity of which point to choose. Here I'm choosing between his legs just for uh, teaching purpose. Okay. So this is how the boys frame should look like at t equals 0 in the trees frame. Any question? Okay, so now let's see where is the location of the tree inside the boys frame. So I can look at the grid line and start counting. The tree is 1, 2, 3. It is 3 meters to the right of the boy. So in the boy's frame, let me go here. So uh, the boy, close enough. Okay, so the boy is always at the center, at the origin of his own frame. And because we can already see that the tree is 3 meters to the right of the boy at t equals 0. So at t equals 0, the tree should be 1, 2, 3, 3 meters to the right of the boy, even in the boy's frame, because this is true no matter where, no matter which frame you're using. The tree is just 3 meters to the right of the boy. So that's where the tree should be at t equals 0 in the boy's frame. Okay? For the y position, the tree is at the x-axis in the boy's frame. So the y position for the tree in the boy's frame is also 0. So that's it for the tree. Okay? We can do the same thing for the ball. So for the ball, let's count again. The ball is at here. It is 1, 2, 3, 4, 5, 6. It is 6 meters to the right of the boy. So I know I need to draw 5, 5, 6. So totally there's 6 meters to the right of the boy, and this is where the ball should be at t equals 0 inside the boy's frame. Okay. So now let me do the same thing for t equals 0.5. So because it is the boy's frame, the frame should always have the origin with the boy. So this is where we should place the frame inside the tree's frame when t is 0.5. You always place the boy's frame on the boy. The boy should always be at the origin. That's the definition of the boy's frame. Okay? So let me do the same thing again. The tree is 1, 2, 2 meters to the right. So in the boy's frame, the tree should not be 3, but just 2 to the right. Just 1, 2. Let me try if I can make it better this way. Make it shorter. No, I don't need. Yeah. Okay, so now I can compare and see that the tree is getting closer to the boy, and indeed it is, because we can see that in the tree's frame, the tree and the boy is indeed getting closer. The distance between two objects should be frame independent. It's always the same, no matter who is watching. Okay? And for the y position of the tree is just 0, so we're done with the tree. Now the problem is the bow. For the bow, it is 1, I prefer blue, 1, 2, 3, 4, 5, 6 to the right, and it is 1, 2, 3, 4, and all right, this is 6, and this is 4 point something. And for this question, I don't expect you to do anything like that is precise. I told you to sketch it, so even though you calculate the position like precisely, your hand is not going to draw it precisely, so it doesn't matter. I'm just going to say it's about 4.7 because it looks closer to the top, so it's about 4.7. Okay? Just estimating this is enough for you to sketch the graph, so don't worry about precision right now. So in the boy's frame, the ball is 1, 2, 3, 4, 5, 6 to the right, and 1, 2, 3, 4.7 to the top. So in the boy's frame, the ball flies up. I know this is 6 and this is 6, so I should make them coincide horizontally. And I'm done with t equals 0.5. Okay. So you can keep doing this for all the other time, and then you can get the trajectory in the boy's frame. And once you get the trajectory, you can get the xt graph and vt graph. Do I need to keep going? Yes, no? Keep going? Stop right here? I'll keep going for a couple of more graphs until you're bored. Okay. So for t equals 1, again, the boy's frame should be at wherever the boy is. And now the tree is just 1 meter to the right of the boy. It's just 1 meter. So in the boy's frame, at t equals 1, the tree should be 1 meter to the right of the boy. So you should just go 1. And this is where the tree is right now, inside the boy's frame. The boy can see that the tree is very close to him, and that is indeed true. So for the ball, again, this is 1, 2, 3, 4, 5, 6, and 1, 2, 3, 4, 5, 6, 7. Okay, so just go 1, 2, 3, 4, 5, 6, and 1, 2, 3, 4, 5, 6, 7, which should be higher than 4.7. If you're graphing it by yourself, you can use like a grid line, or you can denote clearly where exactly is the ball right now in the boy's frame. You can write down that this should be 7 and 6 and 1, because when you plot xt graph, you will know where to put a dot if you have the number. Your trajectory doesn't need to be like accurate, because when you get a trajectory, you should have the numbers, and you just need a number to do the xt plot. You don't really just measure how long is this distance with your ruler and then do the whole thing again. You just measure it once, and then you know this is 7, and you can have your xt plot. So yeah.
Can you show how to do the XT plot
Okay.
the shifted frame of the board one?
Sure. So let me do the xt plot with just these 3 dots. So with these 3 dots, I mean, with just these three states, three times, this is 0, 0.5, and 1. The time is in second, the xy is in meter. I will just say it out without writing them because I'm lazy. You should do it in your homework. I don't need to do homework, so I'm using my privilege. The xt graph will have three dots right now because we see at t equals 0, this is t equals 0. The tree should have x equals 6 in the boys frame. So I just write out where 6 is. Let me do lower. No, it's not 6. 6 is for the ball. 6 is for the ball. The tree is at 3. So if I'm doing the tree, I should do 3 for x and 0 for t. So this graph gives me this point in the xt graph. Does that make sense?
Should the dot be up at the 3 or should it be at the origin?
It should be up. Very good. Now I see why you do confused because it is confusing and I don't know why I made that mistake. Good. You are more awake than I am. Good. So that's for t equals 0. And for t equals 0.5, this graph corresponds to t equals 0.5. So I need to look at this graph and see the tree is at x equals 2. And that gives me this dot at t equals 0.5 and x equals 2. I'll sneak in the unit because I cannot help but be picky about myself. All right, so for t equals 1, it goes to 1, and you have another dot here. So here's your xt graph, and at this point, you can probably tell that it's going to be a straight line. If you cannot tell it's a straight line, just make another dot, then it will be more obvious. Once you see a straight line, then you know the vt graph or vxt graph will be a constant x velocity because the slope of the xt graph is a constant. And it is exactly, if you go right to 1, it goes down by 2. It is from 3 meter to 1 meter, so the x velocity for the tree in the boys frame will be, it goes down by 2 divided by 1 is minus 2 meter per second. So I know I need to plot a negative velocity for the tree. It's going to be minus 2. For the ball, it's going to be trickier because right now if I plot the y position of the ball inside the boys frame, it goes from 0, 4.7 to 7. They do not have equal spacing. 7 is here, 4.7 is here, so it goes like 0 here and here. So you see it's kind of like a curve, and you can just sketch the curve and estimate how much it is to figure out the slope of here and the slope here. In your homework, what I had did for you is I indicated these times. So this is like t equals 0, 0.1, 0.4, 0.5. So you can just use these 2 points to compute a velocity. I mean, compute a, yes, a velocity, and these two to compute a velocity, these two a velocity, these two a velocity, these two a velocity, and then you can have a velocity graph with 5 points. And you can just connect the line with drawings, it's sketching. It doesn't need to be accurate. If you want to choose other dot, in principle you can because I give you all the functions. So in principle you can figure out where the dot should be at any given time. Any any other question? All good. So the deadline of the first homework is extended to tonight, and